Hello students, today you can solve here examples on nth derivatives. In previous video we have solved here nth derivatives of some standard functions. Now you can solve here examples. So see here, find the nth derivative of 1 divided by x plus 2 into x minus 1. Now you can consider here y equal to 1 divided by x plus 2 into x minus 1. Now we have to resolve this into partial fractions. So for this we can take here y equal to 1 divided by x plus 2 into x minus 1. So for this first we can take here, we'll get here x is equal to 1 value is minus 2 and x is equal to 1. So first we can consider x is equal to minus 2. So this value we can put in this here. It is x is equal to minus 2 minus 1 and keep this x plus 2 as it is. In the second term we can take x is equal to 1. So we can, for this we can put here x is equal to 1 in this here 1 plus 2 and keep this x minus 1 as it is. Now so it will become minus 2 minus 1 means we are getting here it is minus 1 by 3 and this is 1 by 3 into 1 divided by x minus 1. So this 1 plus 2 is 3. So next from these two we can take 1 by 3 outside. So remaining is 1 divided by x minus 1 and minus 1 divided by x plus 2. Now to find this nth derivative of these. So you can take here yn is equal to 1 by 3 as it is, and here nth derivative of 1 divided by x minus 1 and nth derivative of 1 divided by x plus 2. So for this we have to use the formula, that is 1 divided by dn of 1 divided by x plus 3. So this is nth derivative of 1 divided by x plus b is minus 1 raised to n into n factorial divided by into a raised to n divided by ax plus b raised to n plus 1. We can use this result. So here a value is 1, b value is minus 1. So we can consider here minus 1 raised to n factorial divided by x minus 1 raised to n plus 1, and nth derivative of 1 divided by x plus 2 is minus 1 raised to n into n factorial divided by x plus 2 into n plus 1. Now from these two we can take here minus 1 raised to n factorial common and divided by 3 as it is. So remaining is here 1 divided by x minus 1 raised to n plus 1 minus 1 divided by x plus 2 raised to n plus 1. So next here nth derivative of 2x minus 1 divided by x minus 2 into x plus 1. So for this also we can consider y equal to 2x minus 1 divided by x minus 2 into x plus 1. We have to resolve this into resolving into partial fractions. So we are getting here one value is x is equal to 2, another value is x is equal to minus 1. So let us we can write this as y equal to 2x minus 1 divided by x minus 2 into x plus 1. So first we can put here x is equal to minus 1. So 2 minus 1 into minus 1 divided by, so only we have to put x is equal to minus 1 in this term. So minus 1 minus 2 into x plus 1. So next here you can put here x is equal to 2. So it will get here 2 into 2 minus 1, x minus 2 you have to keep as it is, and 2 plus 1. So minus 1 minus 2 is minus 3. Here also minus 2 minus 1 is minus 2 minus 1. So minus 3, and this is 2 to 4. 4 minus 1 divided by 2 plus 1 is 3 into x minus 2. So here minus 2 minus 1 is minus 3 divided by minus 3 into x plus 1. So this is 3 divided by 3 into x minus 2. So this is 1 divided by x plus 1, and see 3 will get minus 3 will get cancelled, 3 will get cancelled, remaining is 1 divided by x plus 1 plus 1 divided by x minus 2. Now to find the nth derivative of this. So we can write this as yn equal to dn, that is nth derivative of 1 divided by x plus 1 plus dn of 1 divided by x minus 2. So for this also you have to use the result, that is 1 divided by x plus b. So nth derivative of this is minus 1 raised to n into n factorial divided by x plus 1 raised to n plus 1 minus 1 raised to n factorial divided by x minus 2 raised to n plus 1. So from these two terms we can take minus 1 raised to n factorial common. So remaining is minus 1 divided by x plus 1 raised to n plus 1 plus 1 divided by x minus 2 raised to n plus 1. So next here nth derivative of 1 divided by nth derivative of x square divided by x minus 1 whole square into x minus 2. So let us consider y is equal to x square divided by x minus 1 whole square into x minus 2. So resolving into partial fraction, So you can write this as y equal to first a divided by, because you're getting here x minus 1 whole square, so you can write this as y divided by x minus 1 plus, so for this you get here x is equal to 1 and x is equal to 2. So first you can take x is equal to 1, so it will become 1 square divided by x minus 1 whole square, so plus 1 minus 2. So for this only you have to put x is equal to 1. So next here we'll consider x is equal to 2, so you can put here 2 square divided by, it is 2 minus 1 whole square and x minus 2 as it is. So now we can write this one, a divided by x minus 1 minus, it is minus 1 minus 2 will become, it is minus 1, so it is minus 1 divided by x minus 1 whole square plus 2 square means it is 4, 4 divided by, it is 2 raised to 2 4, and 2 minus 1 is 1, so we're getting here 4 divided by x minus 2. So now for this we have to find here the value of a. So to find the value of a, we have to put x is equal to 0. So if put x is equal to 0, LHS we are getting here 0, and x is equal to 0 means we are getting here, it is x is equal to 0 means it is a divided by minus 1, so we are getting here minus a, and x is equal to 0, again it is minus 1 minus 2. So if we take these values this side, so we are getting here a equal to minus 3. Now to put a is equal to minus 3, so we will get here y equal to, it is minus 3 divided by x minus 1 minus, it is 1 divided by x minus 1 whole square plus 4 divided by x minus 2. Now we can find the nth derivative, so we'll get here yn is equal to minus 3 as it is, nth derivative of 1 divided by x minus 1, next it is nth derivative of 1 divided by x minus 1 whole square it is, next is 4 into dn of 1 divided by x minus 2. Now this is of type here 1 divided by x plus b, so we're getting here minus 3 into minus 1 raised to n into n factorial divided by, it is x minus 1 into raised to n plus 1. So here now we're getting it is x minus 1 whole square. So if you're getting x minus 1 whole square, so you get write this minus 1 raised to n as it is. So now this is x minus 1 whole raised to 2, so it will become here n plus 2 minus 1 whole square. So next this is x minus 1 raised to, it is n plus 2 because it is raised to 2, so we get x minus 1 raised to n plus 2, and this is n minus 1. And this one, it is 4 into minus 1 raised to n factorial divided by x minus 2 raised to n plus 1. So now from all these we can take minus 1, this is n plus 2 minus 1 means we are getting here it is n plus 1, so n plus 1 factorial, so n plus 1 factorial means we can take this as n plus 1 and n factorial. So from all these terms we can take a n factorial outside, so minus 1 raised to n into n factorial, remaining is minus 3 divided by x minus 1 raised to n plus 1, and here so I said this one, that is it is n plus 2 minus 1 means we are getting n plus 1 factorial, n plus 1 factorial can be written as n plus 1 into n factorial, but taken n factorial outside, remaining is 1 n plus 1 divided by x minus 1 raised to n plus 2, and this is 4 divided by x minus 2 raised to n plus 1. So next example is, so to find the nth derivative of log of 2x plus 1 divided by x minus 2. So for this we have to find the nth derivative. So let us consider here y is equal to log of square root of 2x plus 1 divided by x minus 2. Now this is square root, so this can be written as log of 2x plus 1 divided by x minus 2 whole raised to 1 by 2. So this is raised to 1 by 2, so it will become 1 by 2 divided 1 by 2 into log of 2x plus 1 divided by 2x minus 2. This is log of a by b, so we can write this as 1 by 2 outside, log a minus log b. So log of 2x plus 1 minus log of x minus 2. Now for this we have to find the nth derivative. Yn equal to 1 by 2 into nth derivative of log 2x plus 1 and nth derivative of log of x minus 2. Now for this we have to use the result here, nth derivative of log ax plus b, nth derivative of log ax plus b is minus 1 raised to n minus 1, n minus 1 factorial into a raised to n minus 1 divided by ax plus b raised to n. So using this result we can write the nth derivative of log 2x plus 1, so it is minus 1 raised to n minus 1 n minus 1 factorial 2 raised to n minus 1, because the value of in this here the value of a is 2, so we get here 2 raised to n minus 1 divided by 2x plus 1 raised to n. So now here minus 1 raised to n minus 1, so n minus 1 factorial and n minus 1 factorial, here the a value is 1, so and you are getting here x minus 2 raised to n. So from these two we can take my n minus 1 raised to n minus 1 and n minus 1 factorial common, so and divide by 2, so remaining is it is 2 raised to n minus 1 divided by 2x plus 1 raised to n minus 1 divided by x minus 2 raised to n. So this is the answer. So next we can find here the nth derivative of log of x square minus 4. Now for this we can consider here it is log of y equal to log x square minus 4. So this is x square minus 2 square. So we can write this as x minus 2 into x plus 2. So this is log of a into b. So log of a into b is log a plus log b. So it will become log x minus 2 plus log x plus 2. So for this you have to find the nth derivative. So it will become yn is equal to dn log x minus 2 plus dn into log of x plus 2. So again you have to use the result here, log ax plus b, nth derivative of log ax plus b. So it is minus 1 raised to n minus 1, n minus 1 factorial. Here also the a value is 1. So we are getting only it is minus 1 raised to n minus 1, n minus 1 factorial divided by x minus 2 raised to n, and this is minus 1 raised to n minus 1, n minus 1 factorial divided by x plus 2 raised to n. So from these two we can take minus 1 raised to n minus 1, n minus 1 factorial. So remaining is 1 divided by x minus 2 raised to n plus 1 divided by x plus 2 raised to n. Next one is we have to find the nth derivative of sine square x. So we can take here y equal to sine square x. So sine square x can be written as it is 1 minus cos 2x divided by 2. So next we have to find the nth derivative of this. Yn is equal to 1 by 2 and dn of 1 minus cos 2x. So here we can take here it is a constant term. So we can find only the nth derivative of cos 2x. So it is minus 1 by 2 dn of cos 2x. So for this we have to use the nth derivative of cos ax plus b. Nth derivative of cos ax plus b is a raised to n into cos ax plus b raised b plus n pi by 2. Here a value is 2 and here b value is 0. So next we are getting here minus 1 by 2. So it is a raised to n means 2 raised to n cos 2x plus n pi by 2 because b value is 0. So or we can write this as 1 by 2 here. So it can be written as minus 2 raised to n minus 1 cos it is 2x plus n pi by 2. So next we can find here the nth derivative of it is cos 4x. So we can consider y equal to it is cos square raised to square. So it is cos square means here it is we can consider this as whole square here. So cos square means 1 plus cos 2x, it is whole square. 1 plus cos 2x divided by 2. So it will become 1 by 4, 1 plus cos 2x raised to 2. So 1 by 4 expand this one. This is 1 plus 2 cos 2x plus cos square 2x. So now this 1 by 4, 1 plus 2 cos 2x and cos square 2x, because we can't find here the nth derivative of cos square 2x, so we can write this as 1 plus cos 4x divided by 2. So now we can multiply this one by 4 and this 2, 1 by 4 into 2 means 1 by 8 plus it 1 by 4 into 1 by 2 into 1. So 1 by 2 it is 1 by 8. This is 1 by 2 into cos 2x. So next here it is 1 by 4 means here 1 by 8 into cos 4x. So I get here these terms. So for this we have to find the nth derivative. So here nth derivative yn equal to nth derivative of 3 by 8 plus dn of cos 2x plus 1 by 2 into dn of cos 4x. So we can find here, so because it is a constant term, so it will become 0. So we get here 1 by 2 into this one, where this value here, this value is 0. So it is cos 2x means cos ax plus b. So a value is 2 here, 2 raised to n into cos 2x plus n pi by 2. Again you can find the nth derivative of this. This is 1 by 8 into 4 raised to n cos 4x plus n pi by 2. Now we can simplify this one. So this will become 2 raised to n minus 1. Now this is 1 by 8. 1 by 8 means it is 1 by 2 raised to 3. 4 raised to n can be written as 2 raised to 2 whole raised to n. So it will become it is 2 raised to 2n minus 3 cos 4x plus n pi by 2. So this is the answer. So next we can find here the nth derivative of sin square x into cos cube x. So like we can consider y equal to sin square x into cos cube x. So this will become here it is, we can consider this as sin x cos x whole raised to 2. So sin x cos x whole raised to 2. So for this we can write this as sin x cos x whole raised to 2, and we can take 2 and multiply and divide it by 2. So it will become 1 by 4 into, this is 2 sin x cos x is sin square 2x, and this is cos x, and it is 1 by 4 sin square 2x can be written as 1 minus cos 4x divided by 2 and cos x. So next it is, we can multiply this one by 8 into, so it is cos x, and this is also 1 by 8, we can get this common, it will become here minus cos 4x into cos x. So this is 1 cos x, and this is 1 by 2. So we don't have the formula for this also, that is cos x into cos 4x. This is cos a into cos b. So cos a into cos b is 1 by 2 into cos a plus b plus cos a minus b. So this is cos a plus b means 5x plus cos 3x. Next it is, we can simplify this one, so it is 2 cos x, and take this to 16 minus cos 5x and cos 4x. Now for this we have to find the nth derivative. So this is 1 by 16, 2 into nth derivative cos x minus dn into cos 5x plus dn into cos 3x. Now again you have to use the formula cos ax plus b. So 1 by 16, 2 into cos x plus n pi by 2 minus, this is a value is 5 raised to n into cos 5x plus n pi by 2, and this is minus 3 raised to n into cos 3x plus n pi by 2, which is here, this is the required result. So next we'll find the nth derivative of cos x, cos 2x and cos 3x. Now we can consider this as y is equal to this one, and we can write the terms here cos 3x, cos x and cos 2x. This is also cos a into cos b. So cos a into cos b can be written as here, it is cos a plus b and plus cos a minus b. So it will become 1 by 2 into cos 4x cos 2x. Now multiply this one. So this is cos 4x into cos 2x into cos square 2x. So again we can write this as cos a into cos b. So it is 1 by 2 into cos a plus b plus cos of a minus b. It is 4 minus 2. This is again, we don't have formula for cos square 2x. So this can be written as 1 plus cos 4x divided by 2. And this one we can consider this as cos 6x plus cos 2x plus 1. We have taken this 1 by 4 outside here. This is 1 by 2, 1 by, we can take a 1 by 2 outside, 1 by 4 plus 1 plus cos 4x. Now to find the nth derivative of this, yn equal to nth derivative of cos 6x, nth derivative of cos 2x, nth derivative of cos 4x. So it is a constant term, so it will become 0. So again here the value of a is 6, so it will become 6 raised to n cos 6x plus n pi by 2. This is 2 raised to n cos 2x plus n pi by 2. This is cos 4x means 4 raised to n into cos 4x plus n pi by 2. So now we can solve here. We can find the nth derivative of e raised to x sin x into cos 2x. So we can consider the y is equal to this one. Next here we can write this as 1 by 2 into e raised to x. So this is sin a cos b. Sin a cos b is here, it is sin a plus b minus sin a minus b. So it will become sin 3x and sin x. So we can multiply this e raised to x sin 3x, e raised to x sin x. Now to find the nth derivative of this. So it will become 1 by 2 nth derivative of e raised to x into sin 3x minus dn into e raised to x into sin x. So this is of the type here, it is e raised to ax into e raised to nth derivative of e raised to ax sin bx plus c. So e raised to ax sin bx plus c, the formula is here, it is a square plus b square raised to n by 2 e raised to x sin bx plus c plus n into tan inverse of b by a. We can use this result here. So it will become here, it is nth derivative of e raised to x sin 3x, and this is e raised to x into sin x. So here it is of type e raised to ax sin bx plus c. A value is here 1 and b value is 3 and c value is 0. So here also a value is 1, b value is 1 and c value is 0. So it is a square plus b square, 1 square plus c square is 3 square raised to n by 2 e raised to x sin, it is sin a b x plus tan inverse of b by a. So n into, you are getting here, it is so here it is e raised to x sin 3x plus n into tan inverse of b by a. So it is 3 by 1. Now this is a value is 1, b value is 1, 1 square plus 1 square raised to n by 2 e raised to x sin x plus n into tan inverse of b by a. B is 1 and a is also 1. So it will become 1 square plus 3 square means tan raised to n by 2 e raised to x sin 3x plus n. It is here, we can take this, this is also n here. So we'll get here e raised to x sin 3x plus n into tan inverse, it is 3 and it is 3 by 1, so we get only 3. This is 2 raised to n by 2 e raised to x sin x plus n pi by 4, because tan inverse of 1 is, it is pi by 4. So you can write this 10 raised to n by 2 sin, if so from these two you can take e raised to x outside, so e raised to x by 2 10 raised to n by 2 sin 3x plus tan inverse of 3, sin inverse of, we'll get here again, it is tan inverse, it is n into tan inverse 3, and this is minus 2 raised to n by 2 sin x plus, it is n pi by 4. So we can using this result, so we are getting these answer. So this is the required value.